This is Ian Merritt, Aaron Benson, Sean Palmer, and Duncan Ellis, and today we're going to be showing you guys some stuff about the sustainability program in SolidWorks. And basically this will analyze the environmental impact of manufacturing a part that you design, including shipping and stuff like that. So we're going to run a sustainability analysis on a part we already made, this hinge base here. So to get to the sustainability analysis, you go to Tools, SolidWorks Applications, and then open up Sustainability. And you can see at the bottom here, there are two different methodologies that the sustainability will use to run its calculations, the CML and the Tracy. And the CML methodology was developed by the Institute of Environmental Sciences at the University of Leiden in the Netherlands, and it's the most widely used and is considered the most complete of the two. It uses primarily European data to derive its impact factors. And the Tracy method, Tracy stands for Tool for the Reduction and Assessment of Chemical and Other Environmental Impacts, and it's developed by the U.S. Environmental Protection Agency.
So when you look at the SolidWorks program, you're offered a couple initial choices and what you want to do. And so originally this part was designed to be a steel part. So from here we have a certain selection of class materials that range from steel, iron, all the way down to woods, rubbers, and silicons. And so we're going to choose steel for the first one. And for that initial choice of steel type, we're going to do a 1023 carbon sheet steel. And so from there, it'll give us an initial estimated recycled content of that sheet steel. And so all these values that are being pulled from the sustainability program come from another company that's PEM. And so these are kind of standardized environmental regs and kind of data that they've pulled depending on the countries they're being used in and where they're being manufactured in. So that's where these numbers are coming from. So that gives us an initial weight of our material. And so what we can do is we can click Set Material, and so that'll automatically update the material choice over here in our SolidWorks tree. So the next choice we have is where this material is manufactured. And so you have a range of North America, Europe, Asia, Japan, South America, Australia, and India. And so initially for our first choice, we're going to choose Asia. And it's built to last however many years, months, days, and hours. And so from this choice, we're going to say that this part is going to be built to last 10 years. Okay, initially, we can choose the process that this part is going to be put through while it's being manufactured, and that ranges from a die casting, extrusion, forged, machine, and sand casting, milled, none, sand casted, sheet metal, stamped, formed, sheet metal, turned. So we're going to say that this is going to be originally sand casted. And so when you click that sand casting, it'll estimate the total amount of electricity that it takes to make that part, the total amount of natural gas that it takes to make that part, and how much it expects that scrap to happen from that manufacturing process. The next selection that you can make is if it's painted. If it's a water-based paint, solvent-based paint, or powder coating, we're going to say that there is no paint. Okay, now you get to choose where it's used at. And so we're going to choose that this part is being used in North America. And so now this transportation is autofills for you depending on where you chose your manufacturing region and where you chose your usage region. And so SolidWorks knows that in order to get from Asia to the United States, that it'll probably go by boat, and that'll take 12,392 miles. So at the end of life, this is kind of what it's expecting for this type of process, and being its recycling process happening in the United States, it anticipates that you could be able to recycle 33% of this, and that 13% of it's probably going to be incinerated, and that 54% of it's going to end up in the landfill. And so this end of life value is really going to change depending on which country the usage is in. And so from here, it'll update into these environmental impacts. And so this will give you a relative kind of idea of what your environmental impact is with this certain process.
So with these four different types of environmental impacts, you have the carbon impact right here, and the carbon impact discusses the carbon dioxide and other gases which result from the burning of fossil fuels accumulated in the atmosphere, which in turn increases the Earth's average temperature. So really just the amount of carbon output when creating it. The energy output is the total energy consumed. It is a measure of the non-renewable energy sources associated with parts life cycle in this program. And then the air is actually more referring to kind of acid rain It indicates the sulfur dioxide, nitrous oxides, other acidic emissions to air, causing an increase in the acidity of rainwater, which in turn acidifies lakes and soils. And then the last one is the water. The water is when there is an overabundance of nutrients are added to the water ecosystem, and all of the waste products that come from the manufacturing are taken into account for this.
And so once you have those relative levels of environmental impact factors, what you can do is you can set a baseline. And so setting this baseline will set this as your initial process. So say you're a company and this is how you've been making this part forever, and you want to analyze your environmental impact if you changed your manufacturing methods or if you changed where your manufacturing region came from. So now that our baseline's set, by clicking this button down here in the lower right hand corner, we can go back up to our initial selection criteria and change our manufacturing region from Asia to possibly Europe. So after changing that, you can see down here below that the environmental impact shows us what happened to our carbon footprint, our energy usage, our air rate, and our water rate. And it shows that the acid rain produced by this manufacturing process, because of the stricter regulations in Europe, decreases by 63%, and that our carbon footprint decreases by 25%, the energy rate is slightly less at 3%, and the water rate is down by 49%. So that shows that this process is greatly improved by being procured in Europe. So that is also going to change, all of these energy values, these natural gas values, and how much they can expect to scrap. And so from that, what you can do is decide that might be, enough of a sustainability gain for your certain process, or you could also increase your sustainability gains by finding a different material to use in your process. So right now we're using 1023 carbon sheet steel. So if we wanted to find a better material, all we have to do is click the button here that says Find Similar. So that's going to open up a table from SolidWorks that allows you to change all sorts of values from material class to your elastic modulus, to your specific heats, to your yield strengths. So let's say that we want our elastic modulus for this part to be about similar, and that we want our mass density to be less than our current choice, and that we want our yield strength to be greater than our current choice. So all you have to do then is click for a milled process. Let's change our units, keep them in SI, and we're going to click Find Similar. So instead of having to search through that entire list, SolidWorks will automatically update a list of materials that you can choose from. And so that selection criteria might not have been as refined as we previously wanted it because of how many choices it gave us. So if we click on a part here, let's do it's an alloy steel. So this alloy steel will compare its new sustainability and environmental impact compared to that of our original part. So it shows that using an alloy steel is much worse in the air and especially the water rate than our original choice, so that might not be a good option. We can further change our minds by selecting a 50 chromium, and that shows that there's slight environmental gains a little bit from that selection. However, from the sustainability's built-in financial impact, it suspects that the cost of that new material might be 45% more. And so this is another key input that you'd want to check on your costing spreadsheet that SolidWorks also allows you to. So let's say we choose this material. All you have to do is click Accept, and it'll automatically import that into your material specification up here in the sustainability window, and all you have to do is click Set Material, and it updates it here over in your model tree. And so that way you can go back and run your simulation analysis and make sure that material truly works for your given application.
And the last thing that you can do for this is to produce a actual report. So you click the Save As button down below there, and it'll give you the report type that you're going to produce, the part that you've done it on, and then your file location where you're saving it to. And we're just going to wait a second here for it to generate the report. It's thinking about it. Still thinking about it. Still thinking about it. Oh, here it comes. And we have our report. So SolidWorks allows you to, if you're doing this for a company, you can make it nice and pretty, add a logo, name, things like that. And then it'll give you the basic information that it the inputs that you gave it, like the material, recycled content, that sort of thing, and manufacturing region, where it's used, and just a basic summary of the part here you can input pretty easily. Then as you scroll down, it'll also give you kind of another slightly broader summary, and then if we keep going, it'll show you the environmental impacts as presented in the actual SolidWorks program. So here we can actually see the breakdowns of those impacts. So from material, manufacturing, transportation, and end of life. And that's for each of those there. And then pretty much the same thing over again until we get down to the comparisons. So it'll give you the basically breakdown again, and this is just with the bar graphs comparing the baseline material and then your new material that you just updated. It'll also give you a financial comparison as well, which is kind of handy if you're a company and you want to do a cost analysis.
It's also worth mentioning that the SolidWorks program also allows you to do this analysis on an assembly of materials that can be produced from a variety of different manufacturing regions and usage locations. So that's something to investigate later on your own time, but for now, that's all we have. Thanks for watching.
Happy Christmas.